Hello, scholars and friends. This is me again. Here to keep you company on this course that is the course title Operations Management. In the previous lecture, we discussed productivity. Specifically, we talked about the single factor productivity. In this one, we are going to focus on multi-factor productivity. As the name implies, multi-factor productivity, we measure the output relative to a combination of factors or inputs such as labor, capital, and materials. So, with following this approach, provide us with a more comprehensive view of the overall efficiency of the organization that's affected. Overall efficiency, also considering the interplay of multiple resources. In other words, multi-factor productivity takes into account multiple inputs. Like I said, those inputs include or might include labor, capital, and materials. So those factors are now used, instead of using a single factor, use all those factors or more to measure productivity. It gives us a more broader view of efficiency by showing how well a combination of these resources are used to produce goods or services. I think you get the point. Now, there's another concept we're looking at, which is called total productivity. Now, under total productivity, we are looking at the ratio of outputs produced to all inputs used in the production process. Those inputs can include things like labor, material, and capital again, but it measures the overall efficiency utilizing all these resources. So let's look at now how to calculate these things. I'll take you here. Look at this example. It says here that excuse me, that given the output of 100,000 pounds produced at Dengraph Energy Incorporated, sure I've seen this. Okay. With input including 20,000 labor hours. So the output is, let me start from the beginning. Given the output of 100,000 pounds produced at Dengraph Energy Incorporated, with inputs including 20,000 labor hours, a labor cost of $480,000, energy usage of 350,000 kilowatt hour, costing $5,000, and raw materials amounting to 120,000, with a cost of 30,000. You see, answer these questions. What is the multi-factor productivity? That is output per output per non-labor dollar. Then what is the total productivity? So in this question, we are given all this information, and they want us to answer these two questions. So what we're gonna do, let's start with the first thing. The first thing we do is to put these things in. I'm gonna do this. Like I tell my students, you can always use calculators, but Excel make life easy. So I'm gonna show you how you can do this in Excel. So let me show you. And as you want to do it with a calculator, your result might look like this. When you do it with a calculator, it can do like this. See, part of the result. But like I said, I'm gonna do it in Excel. So let's put all this information in Excel and then do the calculation. So this is what I have in Excel. Okay. For the first question, say the output from what they told us is, I wrote that down on paper so I can be looking at it. Output is 100,000, right? Okay, I'm not gonna give more room for this. Okay, the energy got 5,000. as the cost of the energy. That's what they say on the question. Output is in pounds. Okay, so I gotta move this again. All right. The material costs 30,000. Material costs. Okay. So that the what we're looking for is a multi-factor productivity, and the question says calculate what is the multi-factor productivity and what is the labor productivity. So let's go back there and calculate both productivity types. So for the multi-factor productivity, look at the formula right here. Output divided by energy plus material. So that gives us equals output divided by in parentheses energy plus materials, right? Energy plus materials. Okay. Output energy plus materials. That gives us 2.86. Or it was 2.86 there. And then what does this mean for us? Say, once you calculate it, it means that actually, let me put it right here. Let me type the meaning right here so you can see it. But basically, what it means is that excuse me, I picked the wrong thing. Undo. What it means is that it means that the Dengrab Energy Incorporated produces 2.86 pounds. Okay, 2.86 pounds for every dollar spent on non-labor inputs. So mean that Dengrab, I made this to be maybe 18. Mean that Dengrab, okay, Energy Incorporated produces 2.86 pounds for every dollar spent. For every dollar spent on non-dollar, non-dollar inputs, which include, of course, energy plus raw material, energy plus raw materials. Okay. So this is our multi-factor productivity. That's how we can interpret it. Okay. Now, next thing they want us to calculate in that question is the total productivity. In that case, of course, we can do that using this formula here. I'll remove this one. So I want to show you so I can see the formula, how it works. Say output divided by labor plus energy plus materials, okay? Which means that to calculate it, we need the output, right? Equals output. Remember, this is not in dollars. This answer is not in dollars. This is I put it in dollars. It's not in dollars. I think it's gonna be just number general. So I'm gonna okay. All right, let's look at this one. Total productivity gonna be equals output divided by, then put parentheses so that this will follow order of operation. We have there's something missing here, which is the materials. Materials have output. There's something else. Okay, let's look at materials. Materials from that equation. Okay, let me stop this. I'm going to add materials here. Materials. Materials. Oh, materials is right here. There's something else missing. Labor. The labor. Labor that is missing. Okay, labor. So let me add labor here. Labor. Okay. Now, so this we can do everything including labor. Now, if you look at that question, you say that labor costs, say a labor with input including 20,000 labor hours, a labor cost of $180,000. So labor cost is $180,000. So that right here, labor cost 180,000. Okay. So that total productivity now becomes equals output divided by add everything. Energy plus materials plus labor. Close the parentheses and then press enter. Give a 0.47. 0.47. What does this mean? 0.47. Remember this is in currency. Sorry, regular number, not dollars. Number. Yeah. So you can see that it means that Adenga Energy Incorporated produces 0.47 pounds for every dollar spent on all inputs. 0.47 pounds of whatever they produce for every dollar, for each $1 spent on all inputs. That's what it means. So you can see that it's not that difficult to calculate multi-factor productivity and labor productivity. Next thing we'll be looking at is another question, which is on have this one. It says Riverside Metal Works produces cast bronze valves on a 15-person assembly line. On the recent day, 180 valves were produced during a 6-hour shift. Then the question says, what is the labor productivity of the line? Then it says here that the manager of Riverside changed the layout and was able to increase production to 220 units. Okay. Then it says, per 6-hour shift. So it says, what is the new labor productivity? Then number 3 says, what is the percentage of productivity increase? So now it says, they used to produce 180 valves. On the recent day, they produced 180 valves, during a 6-hour shift. Then say, what is the labor productivity of the line? Then the manager now changed the layout of the place and was able to increase production to 220 units. Then it says, for the same 6-hour shift, they say, what is the new labor productivity? And then they want you to calculate the percentage of productivity increase. So now to do that, first thing you need to do is to, of course, like I explained, you can do it with a calculator if you want. Okay. If you use calculator, your results might look like this. You look like this, of course. Put in the right numbers in and get your answers. Now, with Excel, make it just put numbers in. Okay. Unit produced. Well, as you can see, I wrote them down, which is 100,000 units. Okay. Number of workers they have. We have one by, according to the question, let's get the number of workers they have. Go back. It has so 15 person assembly. So they have workers, 15 people as the number of workers that they have, 15 people. So that we have this. Number of workers is 15. Okay. So that we can now go from there. Units produced. Oh, let me look at this again. Let me look at it again. Unit produced. I want to see the this one. Let me. Okay. Look at the question again. Yeah, unit produced. On the recent day, 180 valves were produced. Oh, I wrote 180 by mistake. Okay. So unit produced actually 180 valves. Yeah, that's what I produced. 180 valves were produced. Now, hours worked. Okay. Number of hours worked. We have 6 hours. We say 6-hour shift. I believe that's what it says, right? Let me look at it again. Yeah, on a recent day, 180 valves were produced during a 6-hour shift. So hours worked is 6 hours. Okay. That's 6 hours. Okay. So you have 6 hours. Now labor productivity now becomes, we can calculate that using this formula here. See, becomes equals you have total inputs unit produce, this divided by says total labor input, which means number of workers times hours worked. Number of workers times the hours they worked. I give us 2, which means that 2 valves are produced per labor hour. See, that's what it means. Now, the next thing they want us to calculate is okay, see that the manager at Riverside changed the layout and was able to increase production to 220 units per 6-hour shift. What is the new labor productivity? Okay, so after the layout was changed, so that will give us the new labor productivity, which is equals unit produced this time around. So I'm gonna to calculate that. We have this here as a matter of fact. I'm gonna copy this and paste it here. Since we have it, we have calculated it already before. So all we have to do now is to say, okay, change this to 220, because since we did the calculation already here, so the formula will just translate. See, 2.44. So I can just write here 2.44 units produced. Okay, this guy, 2.44 units. So that means the new labor productivity, is 2.44 units. Let me just make it 2.4 units, 2.4 valves due to the change in layout. Now, you answered that. That question says, okay, what is the percentage productivity? What is the percentage of productivity increase? So to do that, we use this formula here. I'm gonna remove this so I can put it down in one. Percentage productivity increase. In this case, we can say, okay, percentage increase equals the new productivity is this one. I'm gonna put parentheses because it got 2 numbers. This minus the old one, which is this. Close parentheses divided by our old productivity, which is this. That gives us 2.22. Now I change it to percent. 22%. See? 22%. This is the original labor productivity here. This is the new productivity right here. This is the increase. So when I click on the answers, I can see what you did. So that's end this, and it means that for this new increase, mean that the percentage increase in the after the change and the layout, the percentage increase in productivity is 22%. So that's the end of our lecture for today, guys, and hope you enjoy it. Thank you for listening, and I will see you guys in my next presentation. Thank you. Bye-bye.